Have you ever wondered why our planet, so rich in resources, is facing an energy crisis? Imagine a world that's brimming with resources. A world where the energy we need is right at our fingertips. That's our world. Yet, we're grappling with an energy paradox. We're surrounded by energy, but we're neck-deep in an energy crisis. In our quest to power our world, we've relied heavily on fossil fuels. Coal, oil, and natural gas have been the pillars of our energy generation for centuries. But they're not without their drawbacks. They're finite resources and they're running out. More than that, their use has cost us heavily in terms of environmental damage. Greenhouse gas emissions from burning fossil fuels are a leading driver of climate change, contributing to global warming, rising sea levels, and extreme weather events. We've recognized the need for alternatives, for clean and renewable energy sources. Solar and wind power, hydropower, and geothermal energy have all shown promise. They're renewable, they're cleaner, but they come with their own set of challenges. Solar and wind power are dependent on weather conditions. A cloudy day or a calm day can drastically reduce energy generation. Hydropower impacts aquatic ecosystems and requires significant land resources. Geothermal energy, while promising, is location-specific and not available everywhere. In essence, our terrestrial renewable energy sources, while a step in the right direction, are not without their limitations. They are not the silver bullet solution to our energy needs. This brings us to a crucial question. Is there a way to harness clean, renewable energy on a global scale, without the limitations of terrestrial sources? Could there be an energy source so abundant, so powerful, that it could meet our needs without harming our planet? What if the solution to our energy problems lies not on Earth, but in space? Imagine harnessing the power of the sun, not from the Earth, but directly from space. A captivating thought, isn't it? It's not just a sci-fi dream, but a concept that scientists and engineers have been seriously contemplating for years now. This is the intriguing world of space-based solar power. Space-based solar power, or SBSP, is essentially the idea of capturing solar energy directly in space and then transmitting it to Earth. You might be wondering, why space? What's wrong with our conventional Earth-bound solar panels? Well, here's the thing. In space, sunlight is always available, unfiltered by the atmosphere or blocked by clouds. It's a constant, uninterrupted source of energy, 24 hours a day, 7 days a week. Now, how does this work? Picture a giant solar power station floating in the vast expanse of space. It's equipped with a massive array of solar panels to absorb and convert sunlight into electricity. But how do we get this electricity back to Earth? This is where it gets even more fascinating. The electricity generated in space is converted into microwave or laser beams, which are then beamed back to Earth. On our planet, we have what's known as a rectenna, a special type of antenna designed to receive these microwave or laser beams. These rectennas then convert the energy back into electricity, which can be fed into our power grid. It's a complex process, but one that could potentially provide us with a virtually inexhaustible supply of clean, renewable energy. The concept of space-based solar power is not just about generating electricity. It's about reimagining our relationship with energy and the sun. It's about dreaming big and pushing the boundaries of what's possible. It's about seeking solutions to some of the most pressing challenges of our time, from energy security to climate change. Sounds like science fiction, right? But it's closer to reality than you might think. The idea might seem far-fetched now, but with advancements in technology and our ever-growing need for sustainable energy sources, space-based solar power could be a game-changer for our energy future. So, how does space-based solar power work? Let's dive into the details. The process begins with a space solar power station, also known as a solar power satellite. This satellite is deployed in space, typically in geosynchronous orbit about 22,000 miles above Earth's surface. Here, the satellite is perpetually in the sunlight, avoiding the nighttime and atmospheric conditions that limit terrestrial solar power. The satellite is equipped with a massive array of solar panels. These panels are designed to capture and absorb the sunlight that is constantly available in space. Unlike the solar panels on your rooftop, these panels in space would be exposed to the sun's radiant energy 24 hours a day, 365 days a year, without any interruption from clouds or weather. This makes space an ideal location for harnessing solar energy. Once the sunlight is captured, the next step is conversion. The solar energy absorbed by the panels is converted into a form that can be transmitted to Earth. This is where things get a bit sci-fi. The energy is transformed into either microwave or laser energy. Why microwaves or lasers, you might ask? Well, these forms of energy can pass through Earth's atmosphere with minimal loss, ensuring that most of the energy generated in space actually reaches our planet. Now we move on to transmission. The converted microwave or laser energy is beamed from the Space Solar Power Station to a receiving station on Earth, known as a rectenna. This term is a combination of rectifying and antenna, which gives a hint to its function. The rectenna is designed to receive the energy beam and convert it back into electricity. It does so by rectifying the alternating current signal generated by the incoming microwave or laser energy into a direct current signal, which can be fed into the power grid. And voila! The energy that was once sunlight in space is now electricity on Earth, ready to be used to power our homes, factories, and cities. It's worth noting, though, that the technology for all of this is still in the development stages. We've got the basic science figured out, but there are still many technical challenges to be overcome before we can start beaming power down from space. But imagine a future where this technology is commonplace. A future where we have a network of solar power satellites in space, constantly harvesting the sun's energy and beaming it back to Earth. This could provide us with a virtually unlimited source of clean, renewable energy, free from the constraints of fossil fuels and the unpredictability of weather. It's a complex process, but the potential benefits could be enormous. Imagine a world where energy is not just abundant, but also clean and sustainable. That's the promise of space-based solar power. What makes space-based solar power so promising? Imagine a world where energy is abundant, clean, and renewable. A world where the light of the sun, harnessed from the vast expanse of space, powers our homes, fuels our vehicles, and drives our industries. This is the promise of space-based solar power. Space-based solar power, or SBSP, has several distinct advantages that make it a game-changer in the field of energy generation. For starters, the sun shines in space 24 hours a day, 7 days a week, all year round. There are no clouds, no nightfall, no changing seasons to hinder its light. This means that space-based solar panels can capture and convert sunlight into electricity continuously, providing a steady, unbroken stream of power. In contrast, Earth-based solar panels are subject to the whims of the weather and the day-night cycle. They can only generate power when the sun is shining, which, in many parts of the world, is less than half the time. This intermittent nature of terrestrial solar power is one of its biggest drawbacks, limiting its reliability and scalability. But space-based solar power doesn't have this problem. It can deliver consistent, high-intensity solar energy that can be beamed down to Earth as microwave or laser energy and converted back into electricity. This could provide a virtually limitless supply of clean, renewable energy, enough to power the entire world many times over. The potential of SBSP goes beyond just energy generation. It could also play a crucial role in reducing our dependence on fossil fuels. Today, fossil fuels account for more than 2/3 of the world's electricity production, but they are finite resources, and their extraction and use contribute significantly to air pollution and climate change. Space-based solar power offers a way out of this fossil fuel trap. It is a truly sustainable energy source. It produces no greenhouse gases, no harmful byproducts. It doesn't deplete natural resources or damage ecosystems. It's an energy solution that is not just good for us, but good for our planet as well. Moreover, SBSP could be a powerful tool in the fight against climate change. If we can replace a significant portion of our fossil fuel consumption with space-based solar power, we could drastically reduce our carbon emissions. This could help slow down global warming and mitigate some of the worst effects of climate change. But perhaps the most exciting aspect of SBSP is its potential to democratize energy. With the right infrastructure, space-based solar power could be transmitted to any corner of the world, providing energy to remote off-grid areas that currently lack access to reliable electricity. The promise of space-based solar power is truly revolutionary. It could transform our energy landscape, usher in a new era of clean, sustainable power, and help ensure a brighter, greener future for all of humanity. But as with any new technology, there are hurdles to overcome. Venturing into the realm of space-based solar power isn't a walk in the park. It's an audacious journey fraught with numerous challenges that stand between us and a future powered by sunbeams from the cosmos. Firstly, let's talk about technology. We've made impressive strides in space and energy technology, but there's more work to be done. Capturing sunlight in space, converting it into a form that can be transmitted to Earth, and then converting it back into usable electricity is no small feat. We're talking about engineering marvels that need to operate efficiently in the harsh, unforgiving environment of space. The technology required is complex, and while we've made progress, we're not quite there yet. Secondly, the financial aspect. Launching and maintaining solar satellites isn't a low-cost endeavor. It's an investment of gargantuan proportions. The cost of getting the infrastructure into space, maintaining it, and ensuring it operates efficiently is astronomical. And it's not just about the initial investment, it's about guaranteeing a return on that investment. Can we ensure that the energy produced will be cost competitive with other forms of energy? That's a question that still needs answering. Thirdly, there's the matter of regulation. Space-based solar power doesn't fit neatly into our existing legal and regulatory frameworks. Who owns the sun? Who has the right to harvest its energy in space? How do we ensure that the energy beams transmitted to Earth are safe and don't interfere with other satellite operations? These are complex questions that require international cooperation and comprehensive agreements to resolve. Lastly, there are environmental considerations. Yes, space-based solar power promises clean, renewable energy. But we must also consider the environmental impact of launching and maintaining these solar satellites. It's a balance that we need to carefully strike. Yet, despite these challenges, the pursuit of space-based solar power continues. And why wouldn't it? The promise of limitless, clean energy is too tantalizing to ignore. We may have hurdles to overcome, but the prize at the end is well worth the effort. So, what does the future hold for space-based solar power? As we speak, scientists and engineers around the world are making strides in the research and development of space-based solar power, or SBSP. Leading organizations like NASA and the Japan Aerospace Exploration Agency are investing in this future technology, and numerous private companies have also joined the race. The timeline for the deployment of SBSP is still a topic of debate among experts. Some optimists predict that we could see functional SBSP systems in as little as 2 decades. Others, more cautious, forecast a timeline stretching into the second half of the century. The consensus, however, is clear. Space-based solar power is not a question of if, but when. The impact of SBSP on energy generation is expected to be revolutionary. Imagine a world where electricity is generated in space, free from the constraints of weather and daylight hours, and beamed down to anywhere on Earth. This could mean a significant reduction in the reliance on fossil fuels, and a huge step towards meeting global energy needs in a sustainable way. The potential for environmental sustainability is also immense. Space-based solar power could drastically reduce greenhouse gas emissions, as it produces no direct waste or pollution. Moreover, by reducing the need for energy extraction and transportation on Earth, we could minimize the environmental damage caused by these activities. In terms of economic viability, the initial investment for SBSP is high, but the long-term benefits are promising. Once established, the cost of maintaining and operating SBSP systems could be lower than traditional energy sources, as the fuel sunlight is free and inexhaustible. However, it's important to remember that the journey to space-based solar power is not without its hurdles. There are technical challenges to overcome, such as the development of efficient energy transmission systems and the construction of massive structures in space. Regulatory and policy issues also need to be addressed, including the allocation of space for solar power satellites and the management of energy transmission across national borders. Despite these challenges, the pursuit of space-based solar power is gaining momentum. With the continued advancements in space technology and renewable energy, the dream of harnessing the sun's power in space and transmitting it to Earth is becoming more and more attainable. As we look towards the future, it's clear that our quest for clean, renewable energy is leading us beyond the confines of our planet. Space-based solar power represents a bold vision for the future of energy generation, a future where the power of the sun is captured in the vastness of space and delivered to us here on Earth, providing us with an abundant, clean, and sustainable source of power. The future of energy generation may indeed be written in the stars. Before we arrive at the end of this discussion, let's take a breather and ponder on the thoughts we've exchanged. The future of power production is a subject that has a direct impact on everyone, and it's crucial to keep this dialogue alive. That's exactly why we are eager to your voice. What's your opinion on space-based solar power? You see this as the new era of power production? Or do you have some innovative concepts? We encourage to voice your thoughts, opinions, and ideas in the comments section below. Remember, every viewpoint enriches the discussion. If you found this video enlightening and thought-stirring, please show your appreciation with a thumbs up. If you learned something new from the video, then please give a like to the video and share your opinions in the comment. Don't forget to subscribe to our channel for more such enriching content, and also share it with your friends and hit the notification bell icon to stay updated on our newest releases. Let's continue to unravel the future together, one video at a time. And if you believe this video could ignite a captivating discussion among your social circles, don't share it. After all, the advent of power generation is a conversation that we all must be a part of. We are grateful for your active participation in this journey, and as always, keep your eyes on the stars. The future is indeed being scripted there.